All right, learning target 574, we're supposed to make a scatter plot modeling real-world data, write an equation of the fitted line, and then use it to make equations, use the equation to make predictions. So we're going to start by making a scatter plot of the data. And we're measuring X is going to be our years since 1996. And our Y is our TV stations. So we'd have, at the beginning of the study, that's like year 0. Now I'm going from 96 to 2002, so I can go by ones, no problem. My Y values, though, since I start really high, I'm going to heartbeat it, and maybe I'll start at 1500. I've got to get up to 1714, so maybe I'll go by, maybe I'll go by 25s. So 25, 50, 75, there'd be 1600. 1, 2, 3, 1700. Now we're just plotting points. 0, 15, 51. Again, we're just kind of ballparking here. Close enough. When X is 1, I'd have 1563. Maybe about there. 2 would be 1583. Close enough. 3 years later, so 1999, it was at 1616. There's 25, so I don't know, somewhere in there. In 2000, so 4 years later, it was 1730. Really shot up. There's 1725, so 1730 is a little above that. Another year, it went down a little bit to 1686. There's 1675, close enough. And 2002, the next year, there were 1714, so it went back up. 1700, there's about there. So definitely a positive correlation. Things are kind of going up. The number of TV stations is increasing. If I draw a fitted line, maybe something like that. Got a little bit of an outlier that's pulling that line up, this one way up here, but we'll get a pretty good estimate. Okay, so let's take our data, try to come up with a fitted line equation. Maybe I'll use this point here, that's 4, 1675. And another point that I'll use, maybe I'll use, oh, this is pretty close, the y-intercept there, 0, 1550. So find our slope, y-coordinate minus y-coordinate, over x minus x. We're looking at 125 over 4, so we're looking at a slope of 31.25. So our equation then would be y equals our slope times x plus our y-intercept. The y-intercept looks like it's about 1550, and if you compare that to the computer-generated response, we're pretty darn close. It says approximately what rate did the number of TV stations change. Rate is just your slope, so how fast was the number of stations increasing? About 31.25 per year. Approximate the year in which 1,750 television stations would pop up. So we take our equation and now use it. When would we hit 1,750 stations? Subtract 1550 from both sides, and you're going to get 200. Divide by 31.25, and we get 200 divided by 31.25. You're looking at 6.4. Doesn't mean in the year 6.4 there were 1,750 stations. It means that 6.4 years after the study began, which was in 1996, so 6 years later, about 2002 to 2003 is when we would expect there to be 1,750 TV stations. Now, one question that's not asked here is what if they asked you to find the 0 of the function? What does that mean? Well, that means what do you plug in for x so that this thing equals 0? You go through the same steps. You'd subtract 1550, and then you divide by 31.25, and you're looking at negative 49.6. So what does that mean? Well, it means 49.6 years ago, or approximately 50 years ago, there were no TV stations. So you're 50 years before 1996, that's 1946, and yeah, there weren't very many TV stations back then.